Hey guys, we're back, and in this video, we're continuing our discussion on graphing sine and cosine. In previous videos, we looked at how do we identify the amplitude and the period of a sinusoid. And here we're extending that and looking at horizontal and vertical shifts or translations. So we have our generic setup for a sine or even cosine function. We noticed in the previous video how A and B affect the graph. So we're looking at C and D here. So this placement of C, this affects the horizontal shift. And we're going to start calling this horizontal shift a phase shift. Now, the phase shift or the horizontal shift is not C alone. It is actually C divided by B. So when B is 1, our phase shift is just this value. But when B is something other than 1, it changes the phase shift slightly. And then our D, or plus D, this is common throughout all of our functions. When we have x squared plus 2, when I have square root of x plus 5, natural log of x plus 2, that addition subtraction on the very end has the same result. So this is going to be our vertical shift. Probably hear it in the background, my little girl just will not take a nap today. So you might hear her chatter as I'm going through this lesson, maybe give you something additional to listen for. Hopefully she'll take a nap. That sounds really bad, actually, me saying that. But hopefully it's not too much of a distraction. So phase shift, horizontal shift, vertical shift, that's our focus for this lesson. So let's say we want to graph y equals sine of x minus pi over 3. So from the previous lesson, we know that the amplitude of this function is 1, and that the period of this function is going to be, let's see, 2 pi divided by b, which is 1, so just 2 pi. Now this, typically, we went right away and talk about our interval from 0 to 2 pi. That's still the length of one cycle, but with a phase shift, it's not going to be from 0 to 2 pi anymore. It's going to be obviously shifted to the left or to the right. So where exactly will our interval begin and end? Well, I have a little trick for you. We knew previously that it was from 0 to 2 pi. So we're going to place this in between 0 and 2 pi. So it's going to look like 0 less than or equal to x minus pi over 3, and then less than or equal to 2 pi. So we're going to place whatever we have here in between 0 and 2 pi, and we have an inequality we're going to solve for. So I'm going to add pi over 3 to both sides. Okay, because right now our phase shift might not seem too clear. It's going to here soon. So when I do this, we get pi over 3 x, and then 2 pi over 3, that's essentially 6 pi over 3. So 6 pi over 3 plus 1 pi over 3 is 7 pi over 3. So now, from doing this, we can see, going from 0 to pi over 3, that we have a phase shift of, we'll say right pi over 3, okay? So that's how we're seeing this, a phase shift of going right pi over 3. And our interval, writing this down, our interval of one cycle, one full cycle, will be pi over 3, comma, 7 pi over 3. Now, thinking back to what we had to do in the previous lesson, we made a little table to help us graph. So we have x. Okay. So we know we're starting here with pi over 3. 2, 3, 4, 5. All right. So So doing that, so we have 7 pi over 3 on the far right. So we want to know the middle of these two values. So in doing that, I'm going to take pi over 3, add 7 pi over 3, and which would be 8 pi over 3. We want half of that. So half of 8 pi over 3 is 4 pi over 3. Okay? And then looking here, we want half of this interval. So this one might not be so clear. Just think of this. I'm going to do this really verbally, and you can look in the notes attached to see it written down. So 1 pi over 3 plus 4 pi over 3, that's 5 pi over 3. Half of 5 pi over 3 would be, well, I can't divide 5 by 2, so it would be 5 pi over 6. So again, since I could not divide 5 by 2, we multiplied our denominator by 2. So let's see if that works here too. So 4 pi over 3, 7 pi over 3, it's 11 pi over 3. Can't divide 11 by 2, so it's going to be 11 pi over 6. All right? So let's do our next row, which would have been x minus pi over 3, which we know by this point that this is going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So that's a common thing every time. If we just know that, it's going to help us. So now when I go and say I want the sine of x minus pi over 3, sine of 0 is going to be 0. Sine of pi over 2, 1. Sine of pi, 0. Negative 1, and 0 again. So we have exactly what we need to graph. So let's do this. Make our okay. Let's place our axis right there. Why not? All right. So the amplitude is 1. So I just go here 1, negative 1, and every 3 blocks, pi over 2, pi, 3 pi over 2, and 2 pi. But I'm going to go back and write in my individual values. So we have pi over 3, which is right here. 5 pi over, actually pi over 6, guys. I said pi over 6 for pi over 3. So 5 pi over 6, that's going to be right before pi. Then we have 4 pi over 3, so that's going to be pi plus pi over 3, so right here. And then 11 pi over 6 is right before 2 pi. And 7 pi over 3, that's 2 pi plus a pi, plus pi over 3, it's right here. Okay, so you can notice each of these are essentially shifted right pi over 3 from the typical values. So now we go down. So first value, 0. All right, so 5 pi over 6, we're at 1. Then we're at 0. Then we're at negative 1. And back at 0. And we draw our graph. There we go. So with this, we can see how our graph is simply shifted. So using this tracing paper again, placing it where it typically would be without a horizontal shift, we can see that with a minus pi over 3, we shifted to the right that amount. Let's look at another example. So what if we have y equals 3 cosine of x plus pi over 4? So in this one, we can quickly notice that our amplitude is 3. We have a period of 2 pi over 1, or just 2 pi, which is good. So now we're looking at x plus 4. So in here we're thinking, okay, so we have 0, and we're placing an x plus pi over 4, and 2 pi. I want to say this, with our period of 2 pi, that would change this situation when it's not a period of 2 pi, but we have a solution for that, and you'll see within the next couple of examples. So we know I'm going to subtract pi over 4 to both sides, which makes this negative pi over 4, and 2 pi, which is 8 pi over 4, 8 pi over 4 minus pi over 4, which is 7 pi over 4. All right, so here's our interval. And from this, we notice that we have a phase shift. A phase shift of left pi over 4. So bringing the whole graph, is shifting it left that amount. So let's make our table. So we have x. Okay. So see, negative pi over 4. And 1, 2, 3, 4. All right. Okay, so negative pi over 4 plus 7 pi over 4, that is 6 pi over 4. Half of 6 pi over 4, I can divide 6 by 2, so it's 3 pi over 4. So our numerator was even, so I could divide it and leave the denominator the same. And then we have negative pi plus 3 pi over 4, so that's 2 pi over 4, which would end up being just 1 pi over 4. And then 7 pi over 4, 3 pi over 4, it's 10 pi over 4, which dividing that by 2, 5 pi over 4. Okay. So, say 0, 0 pi over 2, pi, 3 pi over 2, and 2 pi. It should be obvious when I state this that this row, or actually this whole process, might not be needed as we become more familiar, but being that this is only the third day into this topic, I really would not be surprised if we need to use this right now. And that's okay. This is just a structure to help us out. So we have that. So now let's do, let's not jump to right away to 3 cosine. Let's just do first cosine of x plus pi over 4. Okay? So cosine of 0 is 1. Cosine of pi over 2 is 0. Negative 1, 0, and 1. So now we can do 3 cosine of that. It's a little crowded, but it's okay. So 1 times 3, 3. 0, negative 0, and positive 3. So graphing this, all right, so typically we say this is 1, we can make it 3 this time. Otherwise, if we kept everything to scale, I'll be going up 12. I'll be going up 12 just for 3. So that would give you really an idea of how much taller, you say taller maybe, taller this is compared to the original cosine graph. So we have that, so we do then, we have a negative. So I'm gonna have to go to negative pi over 2, okay, positive pi over 2, and then pi, 3 pi over 2, and 2 pi. All right, so let's put our actual values down. So negative pi over 4. So pi over 4, we should know, is halfway between 0 and pi over 2. Like 1/4 is half of 1/2. 1/4 is half of 1/2. So we have that. And then positive pi over 4. 3 pi over 4, which is right in between pi over 2 and pi. 5 pi over 4, which is in between the next interval, and 7 pi over 4, which is with the next interval. All right, so 1, 2. Okay, so we have this, and let's plot. Okay, so at negative pi over 4, we're at positive 3, and then at pi over 4, we're at 0. At 3 pi over 4, we're at negative 3, and then 0, and then at 7 pi over 4, we're at positive 3. Okay, so and just like that. So placing our cosine graph on top. Here we are originally. Obviously this is with the amplitude of 1, was the amplitude of 1, but we just see the shift of going left pi over 4. Okay? Let's try another. I have a couple more for us to look at. So this next one, we notice right away how our inner part of the function is different. So just going through this, amplitude of negative 2, positive 2, because the negative conveys a reflection over the x-axis. And then say a period of 2 pi over 3, which can simplify. So our period's 2 pi over 3, and I'm not going to write 0 to, I mean, it would be 0 to 2 pi over 3, but with the phase shift, it's not that. So I'm not, when I do this next portion, I'm not going to do 0 and then I'm not going to place 2 pi over 3 here, but rather I am going to place 2 pi. Yes, it's not, our period's not 2 pi, but when solving this, it will correct itself, okay? So we will always be placing this between 0 and 2 pi, even if our period is different. So first of all, we subtract pi, going through these steps, which gives us negative pi and positive pi. And we divide by 3. And we see our phase shift of left pi over 3. Okay, so with that, we make our table. On our interval, let's write this down, we didn't write this down in the previous example, our interval of 1 cycle would be negative pi over 3 to pi over 3. Okay, so, and graphing it. Okay, so starting with, where are we at? Negative pi over 3. 1, that'd be 3, 4, 5, and it's positive pi over 3. All right, so negative pi over 3 plus pi over 3 is 0, so it's just 0. Okay, so 0, so negative pi over 3 plus 0 is negative pi over 3. When we divide that by 2, my 3 would become a 6. And then same thing here, pi over 3 divided by 0, would be pi over 3 not when we add them, and then we divide by 2. Okay, so then our next row would be, we would write 3x plus pi, And, oh yeah, pi, 0, pi over 2, pi, 3 pi over 2, and 2 pi, followed by cosine of this value. So it would be cosine of 0, 1, 0, negative 1, 0, 1, and then multiplying each of these values by negative 2. And then that would give us negative 2, 0, 2, 0, negative 2. I have a graph. So we look at this, we do have some negative values to worry about here. Let's do this. Okay, and here. So just so you know, negative pi over 3, I need at least 2 boxes for that, so I just gave me some extra room to go to negative pi over 2. And so then that'd be 0, positive pi over 2, pi, so every 3 spaces, 3 pi over 2, and 2 pi, just enough room. So we look at this and we write down negative pi over 3. We need negative pi over 6 too. We need 0. We need positive pi over 6 and positive pi over 3. So right there are the 6 values, or sorry, 5 values. Negative pi over 3. We go down to negative 2. So 1, 2, 3. Put negative 2 right here. Positive 2 would be up here. So negative 2. At negative pi over 6, we're at 0. And positive 2. And then 0. And then negative 2. Okay. So we would have something that looks like this. So let me see if I can extend it this time without messing it up. So it looks to be every line goes negative 2, 0, 2, 0, negative 2. So let's see. 0 here, up to 2, down to 0, down to pi, negative 2, 0, like that. I'm just going to keep going here. I almost made that mistake. There, here, here. Let's see. Okay, so let's see, how many cycles do we get? 1, 2, 3 cycles in here, and it looks like 3.5. 3.5 cycles within this range. And one last example. So you've noticed within these examples so far that we've only been looking at horizontal shifts or phase shifts. And we have yet to look at a vertical translation. And really, vertical translation, I could plot it originally like this and just shift everything up or down by the number that's in the function. But we're also going to use our tables and see how we can use that there. So our function that we're dealing with, very end of all of this. So we have y equals 3x, or y equals 3 minus 2 cosine of 3x. So right away, amplitude of 2, period of, let's see, 2 pi divided by b, which is 3. So there's our period. Now, our period's 2 pi over 3, and I notice that there's no phase shift. Okay, I notice that there's no phase shift in this. So I could technically know it's from 0 to 2 pi over 3. Or if I just do 0, 3x, and then 2 pi divided by 3, right here I can see, oh, 0 to 0, there's no phase shift. Okay, so here's our interval, 0 to 2 pi over 3. So now we have some sort of vertical translation in this problem. So let's say we have x, again, like always, and okay, so we're starting with 0, 2, 3, 4, one more. I believe one more. Yes, yes, yes. and 2 pi over 3. Okay, so 2 pi over 3 divided by 2 is pi over 3. Alright, so then 0, you should know by now, halfway between 0 and pi over 3 is pi over 6. Okay, and if I divide, let's say, pi over 3 plus 2 pi over 3, that is 3 pi over 3, or just pi. We divide that by 2, so pi over 2. So again, this would equal 3 pi over 3, or just pi, and we divide that by 2. Okay. So this we would write 3x, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. So changing the colors here. We have, let's say we have, oh yeah, cosine of 3x. So this is me real quick. So cosine of 0 is 1. Alright, so now we're going to add the 2 in the front of it, not the negative 2, and you'll see why. Just the 2 cosine of 3x. So that gives 2, 0, negative 2, 0, 2. Because the reason why I don't use the negative here is I'm going to do 3, and I'm going to simply say 3 subtract the previous line. So I can say 3 minus 2. Just type in blue. I can say 3 minus 2, which is 1. 3 minus 0, which is 3. 3 minus negative 2, which is going to be positive 5. 3 minus 0 is 3, and 3 minus 2 is 1. Okay, so that is why I did not put the negative there, because I was going to see a subtraction in my last step. So now I'm doing this. So when we go to graph this, let's see, starting at 0. Okay, so writing down our values, so you're at pi over 6, pi over 3, we need pi over 2, and then 2 pi over 3 would be, well, right here. Okay, so at 0, we're at 1. And at pi over 6, we're at 3. At pi over 3, we're at 5. Pi over 2, we're at 3 again. And 2 pi over 3, we're at 1. So this is cosine, remember? So it should make sense that we're getting this shape. So I can continue this. So the next one I know what appears to be right here. And really how I know it's going to come right here is looking at the function. We have a vertical shift of 3. So we took essentially the whole graph that's based around the x-axis, and we shifted that x-axis up to here. So I guess you could call it the baseline. So it's going to pop up, back down, back up, back down, and so on. Okay, yeah, and we see we have 1, 2, 3 full cycles within 2 pi. Okay, so we've done all of the examples that we see here, and we're looking at phase shift, looking at vertical translations, and really how that affects the graphs. There is a lot to practice here, so I wish you the best of luck as you continue mastering this skill. Using the table should become more and more simpler as we go along. Just realized I didn't use the close bracket. Should be simpler as you go along. So best of luck to you, and I'll see you in the next video.